Okay, so we're going to proceed with identifying all the components of an ellipse. That is vertex, co-vertex, focus, and the length of the minor and major axis. So as with parabolas, remember that the first thing you have to identify is the orientation. Remember that the orientation is given by the coefficient that accompanies a variable. That is, the biggest coefficient that is in the denominator is going to determine the orientation. In this exercise, the bigger number accompanies the variable x, meaning that the orientation for this ellipse is going to be horizontal. And thus, because you know that a is always the bigger number, you know that the value of a is the square root of this number. So a equals 7. Thus, if this is a squared, this is going to be b squared, meaning that b is 3. To find the value of c, remember that we have this property in a way that if we solve for c, we have that the difference from a squared minus b squared to the square root of c, at square root is c. Why? Because if I first solve for c, I have this expression. And if I want to get rid of the quadratic exponent for c, I just have to apply a square root on both sides of my equation, and the square root of something raised to the power of 2 is just the original value. Okay? So given that, I can find the value of c. c is going to be a squared minus b squared. So this is the square root of 40. Thus, we can start creating everything. First off, my center, it's defined by the coefficients that are adding or subtracting to the variables. In this case, there's no number accompanying x, so that means the x coefficient is 0, and the y coordinate is going to be minus 3. From there on, the easiest way to start identifying things is to first graph it and then to write the coordinates for the points. So my center is in 0, minus 3. So here's my center. Next, you know that because this is an horizontal ellipse, both the focus and the vertex are going to be horizontal. Why? Because if an ellipse is horizontal, it would look like this, and the vertex are the points that correspond to the widest side of the ellipse. So, and you know also that vertex and focus lie on the same axis. So, for this ellipse, horizontal ellipse, both vertex and focus lie in this axis, and the co-vertexes are going to lie on the opposite direction. So, given that, and because we know that the value of a is 7, remember that the vertex lie at a distance a from the center. So if a is 7, that means that one vertex is at a distance 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4, 5, 6, 7 to the left. If you want to write those coordinates, it's just I landed on minus 7, minus 3, and in 7, minus 3. Now for the co-vertex, I know that my co-vertex lie at a distance b from the center, and b is 3. And I know they lie in an opposite direction from the vertex. So my first co-vertex is 3 above my center, and the other one is 3 below my center. So that gives me in result the coordinates of 0, 0, and the other co-vertex is minus 6, 0. It doesn't matter the order, okay? The last thing we're gonna do is to find the focus. And remember, the focus lie at a distance c from the center, and they lie in the same orientation that the vertex. So if c is square root of 40, remember that this is approximately 6 y cachito. So if I want to find the focus, starting from my center, I'm going to move 1, 2, 3, 4, 5, 6 y cachito. 1, 2, 3, 4, 5, 6 y cachito. Remember, there's no need to be precise. Now, those coordinates are clearly, if I started from my center and I moved horizontally, then one coordinate for my focus is the original coordinate for the center minus the square root of 11, and the other one is 0 plus the square root of 11. In other words, these are just 0 11 square root of 11 comma minus 3 and minus 11 comma minus 3. So given that, I can already graph my ellipse. This is going to look something like this. It has to pass through the vertex, the co-vertex, and that's it. Lastly, the major axis. The major axis is the distance from vertex to vertex. That is the bigger, the wider part of the parabola. Ellipse. So if from vertex to center we have 7, obviously from vertex to vertex we're going to have 2 a's. That is, if from vertex to center this distance is a and this other distance is a, so the distance from vertex to vertex is going to be 2a, and in this case this is 2 times 7, so this is 14. And the other one is going to be the width of our ellipse in its narrow side, so is this one. So the distance from co-vertex to co-vertex is 2 times b, because you know that the distance from the center to co-vertex is b. So 2b is, in this case, 6. So that's how we get all the info from an ellipse. Let's see a vertical example. So that was a spoiler alert. Why? First off, we have to identify the orientation, and that is given by the biggest coefficient in the denominator. In this example, the biggest coefficient in the denominator is below y. That means that my ellipse is going to be vertical. And because the bigger number accompanies y, we know that that number, or the square root of that number, is going to be a. Thus, if this is a, the denominator is going to be b, the square root of the other number. So if we use our relationship between a, b, and c, that is exactly this one, we can find that the value for c is going to be this. So we can apply that. So a squared is 49 minus 25, the square root of, and this is the square root of 24. Thus, let's start writing everything. So my center, first off, is 1, 0. From there, I know that my vertex are going to lie at a distance a from the center. But this is a vertical ellipse, meaning that the vertex and the focus are going to be in a vertical movement. So starting from my vertex, I'm going to move 1, 2, 3, 4, 5, 6, 7 up, and 1, 2, 3, 4, 5, 6, 7 down. Those were my vertex. So the first vertex landed on 1,7, and the other one landed in 1,-7. The next values are my focus. Why not? So the focus, remember, they lie at a distance c from the center, and they have the same orientation than the vertex. So to find the focus, I'm going to move c above and below my center. C is square root of 24, and this is approximately 4 y cachito, or almost 5. So to graph this, you're going to start from the center and you're going to move 1, 2, 3, 4 y cachito. 1, 2, 3, 4 y cachito. So there are our focus. Thus, the coordinates for the focus are starting from a center, I move vertically, so to the y coordinate, I'm going to add the value of c. 0 plus square root of 24. And this is obviously 0 plus square root of 24. Square root of 24 is just square root of 24. And the other focus is going to be 1 comma minus square root of 24. The last points we're going to do are the co-vertex. Because this is a vertical ellipse, the co-vertex are horizontally, and the co-vertex are always at a distance b. So starting from my center, I'm going to move 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here are my co-vertex, and the coordinates for this are 6, 0 and minus 4, 0. So that is enough info so I can sketch my ellipse. And lastly, we know that the major axis is 2 times the value of a, because it's the distance from vertex to vertex. So 2 times the value of a is 14. The minor axis is 2 times the value of b, so this is 10. And that's it.